Hello everyone, let's talk gravity. You know, that thing flat earthers say doesn't exist. It's been quite a popular topic lately, so I got myself into a discussion about gravity just a couple of days ago. And basically the response was what you would expect. When I said, you can just measure gravity, it of course was denied. And when I provided information with a Wikipedia link, it was ridiculed. Now, I was going to make a response showing that childish behavior, but instead of paying any attention to it, why don't I just stick to the facts? So, let's take a look at some ways to measure gravity, and I'll let you guys decide if it is correct. I will be skipping through the principles, but I'll leave links to the proper explanations. Those are a lot better than the explanations I can give, so you'll have to check those out yourself. Basically, you could use a pendulum, a spring, electromagnetism, and you could use a gas in a closed container to measure gravity. For the principle of the pendulum, I will return to Wikipedia. It's actually quite a handy source, so I'm not sure as to why Wikipedia has such a bad reputation. But anyway, as is written here, they have been measuring gravity since the 1600s, so NASA didn't invent gravity. All over the world we find differences in gravitational strength. This varies up to 0.5%. Now, I happen to live in the tiny country of the Netherlands, where you could measure quite a difference in gravitational strength. Now, anyway, in the beginning they used a seconds pendulum, where a weight on a bar makes one complete swing from the middle to its maximum swing point on one side back to the middle in 1 second. This is how Quartz pendulum works. Quartz pendulum is connected to a clock, so you can measure it makes exactly 2 complete swings in 2 seconds. When you move the pendulum and it now makes more than 2 complete swings in 2 seconds or less than 2 swings in 2 seconds, you know there's a difference in the gravitational strength. The strength of the gravity is proportional to the length of the bar, so you can change the length of the bar to make the pendulum swing exactly 2 complete swings in 2 seconds. You can calculate the difference in the gravitational strength based upon the difference in the length of the bar. If there is no gravity, you would never have to change the length of the bar, it would always make 2 swings in 2 seconds. Important here is the air pressure. It needs to be the same so the resistance is equal and you don't have a difference in air density. Then the difference can only be caused by gravity. Instead of a pendulum, nowadays they use different methods. Most gravimeters use a sensitive quartz spring. In a closed box where the air density never changes, you hang a weight on a quartz spring. The spring will be stretched out a bit by the weight. So when you know the length of the spring is stretched and you know the strength of the gravity at this location, this is the default measurement, which you can now compare to other locations. The circumstances inside the box do not change. There is no difference in air pressure or air density. When you are at a different location with a different gravitational strength, the quartz spring is stretched further or less far than at the default measurement. So again, you can calculate the difference in the gravitational field. If there is no gravity, there would be no difference in how far the spring stretches. Now, both the pendulum and the quartz spring are accelerometers, but you have 2 more methods to measuring gravitational differences. You could also use electromagnetism. What you see in this video is a magnet being dropped through a tube. At several equally divided points there is a copper coil around the tube. As the magnet passes a coil, it produces a short electric current. You can measure the time between the electric spikes, and you can see this on an oscilloscope and put it in a graph. When you do this test on different locations in similar circumstances with the same air pressure or air density, you can compare the graphs you've made at both locations. When they are not equal, there's a difference in the gravitational strength because the magnet falls faster or slower. Now, the principle is well explained in this video, so I'll leave the links in the description. If gravity doesn't exist, all graphs with the electric spikes would always be the same. The last way which I found to measure differences in gravity is with gas. To me, this is quite complex, but basically, as I understand it, you have a reference chamber filled with gas and a measuring chamber to measure the difference. They measure the molecular weight of the gas and they measure the gravity of the Earth. As the gas has a molecular weight and thus its own gravity, like all matter has, you can make a comparison and measure gravity more accurate. You should check out this video, which provides an accurate explanation. So basically, those are the four ways I found. And I wonder what the flat earthers think of this. You just let me know what you think in the comments. Thanks for watching.